Hi. Today we're going to deep dive into engineering behind one of the most talked about capabilities in AI right now, Claude's massive context window and its ability to reason across huge documents without falling apart. We are going to look at the actual architectural decisions, the training choices, and the specific design trade-offs that give Claude a measurable edge. Let's get into it. Let's build the foundation. A context window is simply the number of tokens, that is, the chunks of text, a model can process in a single pass. But scaling up it is not very trivial. The standard transformer attention mechanism is big O of n squared, that is, every token needs to look at every other token. That means doubling the context quadruples the compute. And even if you have the compute, you hit memory walls because of the KV cache, that is the memory of what the model has already seen, because that grows linearly and that can become enormous too. And here's a dirty secret. Most models quietly degrade in accuracy long before their advertised context limit. Claude was engineered specifically to fight all these three problems. Now let's get a little technical. The key architectural insight Anthropic used is you don't need every token to attend to every other token to preserve coherence. Sparse attention patterns allow the model to attend locally within a window of nearby tokens, plus to a small set of global anchor tokens that carry long range information. This breaks the quadratic wall. And on top of that, flash attention, a hardware aware algorithm developed by Tredow's group, lets Claude process long sequences without blowing up GPU memory. And critically, unlike alibi positional encoding used in GPT-4o, Claude doesn't systematically penalize early tokens. That's why Claude actually reads and uses the beginning of a long document, not just the recent parts. The KV cache is where long context models go to die. Every token you process creates a key value pair that needs to be stored in GPU memory for the rest of the generation. At 200,000 tokens, that's enormous. Claude tackles this with grouped query attention, that is, multiple query heads share key value heads. Think of it like having one whiteboard that multiple students can reference instead of each student needing their own copy. So the result is around 6 to 8 times reduction in KV cache memory with minimal quality impact. And Anthropic also built something called the prompt caching directly into their infrastructure. So if you're asking multiple questions about the same document, the cache is reused. Your first query might take 30 seconds, but subsequent queries on the same document run in milliseconds. Position encoding is the unglamorous detail that determines whether your long context model actually works. GPT models using alibi bake in a structural bias, that is, every position further away gets a penalty. So the model literally learns to care less about things earlier in the document. Rope, which Claude uses, encodes position as rotations in a complex number space. The magic is it's pretty relative. So the model learns relationships between positions and not absolute addresses. Combined with Anthropic's rope scaling technique, Claude can generalize to sequences far beyond what it saw in training without position embeddings going out of distribution. And this is why Claude can open a 500-page PDF and actually reference page 3 when answering a question on page 497. See, but architecture creates a capability, training creates the behavior, and this is where Anthropic's research background becomes a real competitive advantage. Their constitutional AI framework isn't just about safety, it explicitly trains the model to be accurate and grounded when working with documents. Anthropic uses needle in a haystack tasks during training, that is, synthetic documents with a key fact buried at different positions, and the model is trained to retrieve it correctly regardless of the position. On the scrolls benchmark, which specifically tests long document reasoning, Claude shows the flattest accuracy curve, meaning it doesn't dramatically degrade when facts are buried in the middle of a long document. GPT-4 and Gemini both show more degradation in that middle region. Now let's talk a little bit about numbers. On the lost in the middle evaluation, where you have around 100,000 token context and bury the key fact at various positions, Claude scores around 90 to 92% accuracy flat across positions. GPT-4o drops to around 70 to 75% when the fact is in the middle section. That's not a small gap when you are processing legal contracts, medical records, or code bases. On multi document citation accuracy, Claude consistently outperforms because of its training, not just its architecture. And on latency, despite the massive context, Claude's GQ and Flash attention integration means it's actually faster to first token than GPT-4o at comparable context lengths. Now let's ground this in reality. Legal teams are using Claude to load entire contracts and ask adversarial questions about conflicting clauses, something that would require a complex RAG pipeline with any other model. Software engineers are loading entire repos and asking for architectural explanations. Researchers are doing real literature synthesis across 15 papers in a single context, not through retrieval augmented search that loses nuance. Financial analysts are processing entire 10K filings. In every case, the advantage is no chunking, no information loss at boundaries, no retrieval error. You get the full picture in one shot. So that's compounding return of genuinely long, accurate context. And here's why this advantage doesn't evaporate overnight. It's not a single trick, it's a co-design stack. Anthropic built the model architecture, the training procedure, the constitutional AI framework, and the serving infrastructure together. Flash attention is tuned for their model, prompt caching is native to their API. GQA parameters were chosen to match their training distribution and their interpretability research. That is, they can actually look inside the model and see which attention heads handle long range retrieval, meaning they can surgically improve exactly the right components. Most competitors are assembling these pieces from different sources, but Anthropic built the whole clock. So let's recap. Claude's long context dominance isn't one thing, it's five things compounding. 1. Row positional encoding with yarn scaling means no structural bias against early tokens. 2. Sparse attention and flash attention break the quadratic wall. 3. Grouped query attention slashes KV memory by 6 to 8 times. 4. Constitutional AI needle in a haystack training create accurate retrieval behavior regardless of where facts appear. 5. Prompt caching at the infrastructure level makes multi-turn document analysis cheap. Any one of these alone is a modest improvement. All five together, co-designed and tuned against each other, is a durable architectural advantage. That's the engineering behind Claude's context window, and that's why it's leading the race.